So in thermodynamics, we're often concerned with whether or not a reaction actually occurs. So a process or reaction is said to be spontaneous if it occurs without outside intervention. And this does not have anything to do with the speed of the reaction. A spontaneous reaction can be really fast or very, very slow. So for example, the melting of ice is spontaneous above 0 degrees Celsius, but it's not spontaneous below 0 degrees Celsius, its melting point. So we know that things like to be at low energy. So we can assume that exothermic reactions are more likely to be spontaneous. So nature likes exothermic reactions because the reactants and products can be at a lower energy level after the reaction. But there's one other property that we have to take into account when determining whether or not a process is spontaneous. And so this actually is the main driving force for a spontaneous process. And so exothermic, whether or not a reaction is exothermic or endothermic, is not as important as this new property, which is entropy. And so entropy is basically a measure of the amount of disorder or randomness in a system. And you can also think of it in terms of probability. If a system has more randomness, more disorder, it's a state with a higher probability of existing. For example, if you shuffle a deck of cards, there's a very, very small chance that the cards are going to be in order. 1, 2, 3, 4, or 2, 3, 4, 5, 6, and so on. And so, if the cards are all mixed up, you say they're in disorder, and that disordered state has a higher probability of existing than the ordered state, in which they would all be, numerically numbered in order. So, nature spontaneously proceeds, or nature prefers, states with more disorder. So nature likes more entropy. So if we compare the entropies of the three phases of matter, gas, liquid, solid, in solids, the molecules or atoms are kind of all packed together in a crystal. So there's very little disorder. And then in a liquid, they're starting to slide around a bit, but in a gas, they're totally apart and moving and bouncing in all random directions. So gases have much higher entropy than liquids or solids. While liquids do have some higher entropy than a solid. So the second law of thermodynamics says that for a spontaneous process, the entropy of the universe always increases. So if we don't have more entropy in the universe, the reaction does not happen spontaneously. So the total change in entropy for the universe can be split into the delta S for the system, the reactants and products, plus the delta S for the surroundings. So if these two delta S do not add to a positive number, then that means the total entropy of the universe did not increase during that process, so it is not spontaneous. So first we're going to be looking at the delta S for the surroundings in a reaction. So the entropy change in the surroundings of a reaction mainly depends on the heat flow, in other words, the delta H of that reaction. So if we have, let's say, an exothermic reaction, now that's going to release energy into its surroundings. And that energy that is now in the surroundings is going to heat up the surroundings, increasing the random motions of these molecules. Remember, temperature is just a measure of random motion. So now in the surroundings we have more random motion and therefore more entropy. So an exothermic reaction increases the entropy of its surroundings. And opposite, an endothermic reaction will absorb heat from the surroundings and decrease its entropy because things are moving slower now. So the impact of this transfer of energy to and from the surroundings has a greater impact on the entropy at lower temperatures. So, for example, if we have say this is happening at 0 degrees Celsius, so things in the surroundings are moving pretty slow. And then we have an exothermic reaction releasing all this energy into the surroundings, and now it's moving really fast. So there's a very large change in entropy in the surroundings. Whereas if that reaction took place at 200 degrees Celsius, the surroundings are already moving pretty fast. There's already a lot of entropy in the surroundings. So that little bit of extra energy from the reaction does not really have a big impact. Another way to think about this is if you give $50 to a really poor guy, that's a big difference in his life. But if you give $50 to a millionaire, he doesn't really care because he already has so much money. So now we can define the change in entropy for the surroundings. So delta S for the surroundings in a reaction will equal negative delta H for that reaction over the Kelvin temperature. And then we have this negative sign because, as we mentioned, if delta H for that reaction is exothermic, which means delta H is negative, then delta S for the surroundings should be positive. And so from here, you can also see the units of entropy. Entropy is joules over Kelvin. So we have one more property that kind of ties together the enthalpy and entropy, and that is free energy, which is defined as G equals H enthalpy minus temperature times entropy. And so this is the one property that we need to look at to determine whether or not a reaction is spontaneous. So if delta G, the change in free energy for a reaction, is negative, then it is always spontaneous. If delta G is positive, then it is always non-spontaneous. So at constant temperature, delta G equals delta H minus T times delta S. So we're going to be using this formula a lot to determine the delta G. And this is the main way to find delta G for a reaction, just by knowing delta H, delta S, and temperature. And watch out for the units when using this equation, because delta S is usually given in joules per Kelvin, while delta H is usually given in kilojoules. So you're going to have to convert between the two. And so we already talked about this. Nature favors exothermic reactions, which is negative delta H, and also positive entropy, so positive delta S. So looking at this equation, you can see that if delta H is positive and delta S is negative, you're going to have a positive number minus a negative number, or in other words, a plus. So this number, delta G, will always be positive. So if delta H is positive and delta S is negative, the reaction can never be spontaneous. So this means that nature, it always wants one of two things, if not both. It always wants negative delta H or positive delta S. If we have both of these things, the reaction is always spontaneous because we always get a negative number here. Now if we have one of the two but not the other, then we have to look at this equation. So it's going to depend on this temperature multiplying the delta S.